Alright, this is a video to review how to do the nonlinear regression. I'm going to do the second in-class example since I did the first one with you in class. So to start off, you should always clear your calculator, second plus 712, to restore it back to the default settings. After that, don't forget to turn your diagnostics on by going to Mode, scroll up to Stat Diagnostics, and turn it on. You need to do that every time you reset when you're doing regression. So I will type this data in: 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 600, 700, 800, 900. And then in L2, 0.6, 0.58, 0.56, 0.55, 0.53, 0.52, 0.5, 0.49, 0.48, 0.46, 0.44, 0.42, 0.4, 0.38. Okay, so I have all those numbers typed in, hopefully correctly. Your next step should be to do linear regression. You can do 4 or 8, it doesn't matter. Remember, they are the same thing, except if you do a plus bx, a is the y-intercept. If you do ax plus b, a is the slope. Calculate. So we have a pretty high r, but remember that doesn't guarantee that it's a linear function or that the linear model is appropriate. If we go to the stat plot, let's turn that on. I'm just going to start off by looking at the original data with L1 and L2. So zoom 9. If you just glance at the points, they appear to be in a straight line, but if you look carefully, you can see the curve. But that's not always easy to see on the residual plot, so it's not always easy to see on the scatter plot, which is why we look at the residual plot. To get your residual plot, you do second stat plot, turn it on, L1, and then my Y list I want to be the residuals. To get there, I do second list, and the residuals are down at the bottom. Remember, you have to do linear regression before, which I already did, but the residuals don't even show up if you haven't done linreg. And it's going to be the residuals for the last linear regression. Zoom 9, and now I can see that parabolic pattern much easier. So the linear model is not appropriate. Before this lesson, that's as far as you had gotten, is determining if the linear model is or is not appropriate. Now we're going to talk about what to do if it's not appropriate. So we try out one of the given transformations, which right now these are the models we're dealing with. For this class, these are the only models we'll deal with. So x and y was not appropriate. So I'm going to try my next model, x and log y. So I want the x's. I have those stored in L1. You don't have to write the list above it, but it can help you, especially if you're getting confused with where the things are located. Go to the top of L3 and do the log of the y values, which are located in L2. So I stored these in L3. I do linear regression again on L1 and L3 this time. Calculate. The R is pretty similar, but remember I need to look at the residuals to determine if it's appropriate. For my residuals, I want it to be the x's, which are L1, and the residuals. They're going to be different residuals, so I have to zoom 9 again. That looks a little bit more random, but it's still kind of got that pattern to it. So I'm not going to cross it out just yet, but I think I could do better than this graph. So we'll try the next one. So I already have log y stored in L3, so I'll leave it there. And I'll go to L4, go to the top of L4, and do log of L1. And then stat calc, I stored this in L4, linreg, So I do L4 and L3. Calculate it. So the R is not a strong, but that's not what determines the linearness or the appropriateness. Change your X list to L4 since we're doing log of X. Did I do that here? Yes, I did do L4 and L3. Make sure you do it here, L4, zoom 9. Here we have a very definite pattern, so log X and log Y is definitely not okay. So let's try the next one. I'm going to clear out both of these lists so I don't get confused, but some people prefer to leave them in and move and keep changing the other things. So X's are in L1, square root of Y is L3, second square root L2, which I get by doing second 2, stat calc lin reg on L1 and L3. And then change your X list back to L1. So it only needs to change for log X and log Y, but don't forget to change it back. Zoom 9. Okay, and we've got, again, that same pattern that we had in the first graph, so this is no good. So last one. Go to the top of L3, clear it out, go back. 1 divided by L2, stat calc lin reg, L1 and L3, and we've already got the L1, so we zoom 9, and this one is definitely more random than this one was, so this is definitely our model. Your next step is to write your linear equation. So stat calc lin reg, L1 and L3. When you write the equation, it's almost exactly the same. The only difference is you write your transformed values. So in this case, X stayed the same, so I would just write X, but Y became 1 over Y. So instead of writing Y, I write 1 over Y, but don't forget your hat. Equals, I chose A plus BX, so A is 1.6026 plus B, which is 0.0011 times X. So this is my linear equation. Don't forget to define your variables. X is equal to the number of orange trees the number of oranges per tree, and Y is equal to the average weight per fruit, which is measured in pounds. And another part of the question could ask you to predict Y if X is equal to, say, 325. It'll use words instead of symbols, but this is fine. So I do the same thing I did before. I plug my X value in for X. So I type in the right-hand side since there's not any variables. So 1 over Y hat equals 1.9601. I still need to isolate Y hat. This is where you're going to have to use your algebra skills. For this one, I'm going to multiply both sides by Y hat to get Y out of the denominator and back in the numerator. So now we have 1.9601 times y hat. To get rid of 1.9601, I'll divide. So I'll plug that in to get my y hat value. 0.5102. And the units for y was pounds per fruit. So that is a general overview of the nonlinear regression. You can try this example again on your own. You can also try one of the 4 homework problems again on your own. Come into tutoring if you have any questions. That's all I have for you.